Hello everyone, welcome back. We are happy that you are with us again. Now we would like to start the second part of Smart Infrastructure Conference.
Well, firstly, a short message from the organizers. We have so many calls, questions, people asking to join our conference. So we decided to open the registration system since 2 p.m. It will be open until 9 p.m. Of course, the Central Europe time. Tak więc informacja dla wszystkich, którzy nie zdążyli się zarejestrować. Otwieramy jeszcze system rejestracji. Będzie otwarty od godziny 14 do 21. Ci, którzy nie zdążyli, serdecznie zapraszam. Now we are pleased to welcome Mr. Zsombor Barta, President of Hungary Green Building Council. Let's hear about the latest Hungarian infrastructure developments and plans. Zsombor, over to you.
Hello and welcome to the presentation about smart technologies, about sustainability and BIM in the Hungarian context. My name is Zsombor Barta, the current president of the Hungary Green Building Council. If it comes to BIM in Hungary, then on the one hand side, Hungary has a very prominent position because the world's first BIM-based software was developed by the Hungarian company Graphisoft. Architect is known and commonly used by international audience, by architects and professionals worldwide. Further, the Hungarian government had also several aspirations to emphasize the importance of BIM for the Hungarian professionals. First of all, the Hungarian BIM Standard Working Group was established in 2015 by the Hungarian Standardization Institute. The Hungarian government issued also a so-called BIM manual in 2018, which emphasizes the positive effects and importance of BIM for the Hungarian architects and Hungarian building professionals. And further, from last year, a government decree said that the importance of evaluation of BIM for the Hungarian building sector should be emphasized as well. However, if it comes to public building development or public construction or government-related projects, unfortunately BIM is not as commonly and frequently used as we would wish. Of course, private companies and private developers are also using BIM in Hungary, but unfortunately BIM is not as widely used by the Hungarian professionals as we would like to see or we would like to have. This is unfortunately the current situation. However, on the other hand side, the government is doing a lot in terms of digitalization of the Hungarian society, and therefore they established also the so-called Digital Success Program. The Digital Success Program is about widely digitalization of the society on different levels, and one of their major elements is the development of smart city program and smart city developments throughout the country. And this is, as I said, also emphasized and highlighted by this Digital Success Program run by the government. Smart city strategies of almost all bigger Hungarian cities exist, and these strategies are connecting not only smart technologies but also the importance of sustainable development for the municipalities as well. Further, the livability is one of the major issues which is coming more and more into the focus areas, and this is highlighted and emphasized by many NGOs, by private organizations, and by the people in general. The next slide is showing the program elements of this digital success program of the Hungarian government. As I said, the program elements are covering almost all areas of life, but the most important related to the building industry and built environment is the smart city technology and smart city developments in general, which is included into this program as well. If you are looking to the Hungarian situation in a global context, then the World Economic Forum's Global Competitiveness Report from last year, 2019, is giving us an interesting comparison between the countries worldwide. The overall ranking of Hungary is at rank 47, which is a middle average out of the 140 countries globally. And if it comes to the Visegrad countries, then unfortunately Hungary has currently the last position in that respective, on that competitiveness ranking. In brackets, I'm also showing the other Visegrad countries ranking in this competitiveness report. This report is based on several indicators which are also showing different rankings in different fields and in different areas. So if you are going a little bit deeper and behind this overall ranking and looking especially to the infrastructure or to the transport infrastructure or to railroad, for example, then you can see that Hungary and overall the Visegrad countries have a quite good ranking if it comes to transport infrastructure or especially for railroad density, where Hungary has the rank 9 globally, which is excellent. So this ranking shows that on the one hand side, the overall ranking of competitiveness in Hungary is average. However, if it comes to infrastructure, especially to transport infrastructure, Hungary has a quite good position in that indicator. However, the government is emphasizing new transport infrastructure developments for the upcoming years, and I wanted just to show you the major ones. First of all, the Budapest-Belgrade railway connection, which is part of a much bigger global transport route and transport network, which is connecting the Mediterranean Sea and Greece with Belgrade, Budapest, Prague, and of course the rest of Europe and the heart of Europe. And goods can be transported directly via sea from China through the ports of Greece and then further on railway to the heart of the continent. This is a major development which is ongoing and will be constructed within the upcoming years, and of course this is something which is also has a very high priority for the Hungarian government, and the project is also partially financed by Chinese companies and by the Chinese government. The road infrastructure developments of the upcoming years showing also big and huge activities, because more than 25 projects will be realized in the upcoming years. That means that more than 800 kilometers of new roads will be constructed in Hungary. Again, we should remember what I have shown you on the previous slides regarding the global competitiveness and the special indicators related to transport infrastructure. Hungary has there already a very strong position. However, this position will be even more strengthened according to the governmental programs of the upcoming years, as just shown, related to the railroad redevelopments or the road developments. However, of course, if it comes to sustainability, then we have many challenges. First of all, the infrastructure which we have has to be maintained and kept in a good condition. Even a German car manufacturer had an international commercial run on TV, which shows one of their new cars and emphasized that they can provide comfortable space within this car, even on such bad roads like Budapest has. So even the international public and visitors know about the relatively poor condition of Hungarian roads. And this is indeed something which should be tackled and measured and mitigated in the upcoming years, because on the one hand side we have a good railroad and road network on the one hand side. However, their condition and maintenance should be emphasized as well. If it comes to built environment and sustainability, then the material use of the building sector is one of the major negative elements which must be also emphasized in that perspective. The OECD's material resources outlook until 2060 shows also a dramatic development in that perspective, because the material usage will be more than 2 times bigger than it was in 2011, according to this report from 2019. And this material usage globally is related directly, the majority of this material usage is related directly, unfortunately, to the building sector, to the built environment. This is unfortunately a fact. Also, that the growth of paved and sealed surfaces is continuously growing, especially in Hungary. The Eurostat data shows that the Hungarian sealed surfaces grew between 2009 and 2015 by 14%, which gives us the 3rd rank within the EU countries if it comes to sealed surfaces and paved surfaces. The Hungarian Statistic Office shows also an interesting graph. They are showing on the one hand side with red dots the demographic developments of Hungary, and in the other hand side they are showing with orange dots the growth of paved and sealed surfaces in the country. As again it's shown, and it's again something which is not sustainable, that less and less people are living in Hungary, less and less people are using the country, but we are paving and covering and sealing more and more surfaces, more and more green surfaces and areas in the country, which is of course cannot be sustainable, and it's also alarming on the one hand side. Therefore, our recommendation is to use and to reuse the many brownfields and the built-in areas which we have in the country. Contaminated sites should be also reused in order to minimize the negative impacts of land use in general, which is related to the building sector and built environment. The use of smart technologies such as BIM during design, construction and operation and maintenance should be also emphasized in order to minimize the material usage and increase efficiency. This conference is partially about these technologies and about these issues. The incorporation of smart and sustainable technologies and methodologies can also increase the livability of built environment, which is, again, should be on a very high priority, because at the end people are using the built infrastructures, the built environment, and therefore their livability and long-term sustainability should be something which should be emphasized during all of the upcoming projects and works which are carried out by the building industry. Thank you very much for your time and for your interest.
Thank you, Zsombor, for interesting presentation about innovative technologies and Hungarian context, and the voice from Budapest, which I love the best. Sylvia, let's go back to the British expertise.
Why digital asset is important? What are the principles it should follow? How to create it? Mr. Jakub Wachocki from Bentley Institute will try to answer these questions in his presentation, Digital Twin Strategies Enabling Smart Infrastructure. Jakub, the floor is yours.
All right, I hope you can hear me well. Thank you very much for inviting me. I'm Jakub Wachocki. I'm going to talk to you today about the digital twin strategies enabling smart infrastructure. So first of all, I want to cover a little bit about what is smart infrastructure. For me, smart infrastructure is really infrastructure I can query. So it's the ability to find things. And you can see here an example of an inspection engineer who is able to access information anytime, anywhere, or even contextually. but it's also infrastructure I can interact with. So here I have put together two examples enabled by augmented reality technology. So they provide you the ability to interact with things again, visualize them, comment on them, understand the infrastructure assets much better. It's also infrastructure I can talk to. So imagine being able to use voice control to interact with a twin. You can ask things like who is responsible for installing or maintaining the pump, or other type of queries. It's also infrastructure I can inspect remotely. So here we are providing the ability to recognize things without human intervention. And these examples here, we are recognizing the cracks on the bridge. These are examples from Singapore and Australia. And below, the image below, you see how we are able to recognize objects and potentially create 3D model out of photographies. So here we are adopting machine learning algorithms for remote inspection. It's also infrastructure I can control. So here, again, there's an example of a dashboard where you can actually, let me turn this on, you can actually start to have full control over project schedule, project costs, or other performance indicators. But again, it's about pulling these different data sets together to have a unified view. It's also infrastructure I can monitor. So here I'm giving an example of a digital twin we have created for this is an energy plant, a power plant, and we are able to monitor the performance, the operating performance of a particular asset. Now, staying with the concept of monitoring, here I have put together an example for decision support. This is a tunnel. We worked together on this particular example with Microsoft to understand how can we monitor, for instance, the CO2 emissions in a tunnel. And we are able to install particular sensors that will spot anomalies. In this particular case, you will see that the CO2 level or other gases emissions go up. We can trigger certain alerts. We can also inspect the particular tunnel through cameras based on those alerts and potentially plan for any required interventions based on this scenario. Last example from the infrastructure, this is a water infrastructure. We're able to monitor networks condition, overflow, or again, performance across the entire water network. So these are some of the examples that I've put together for you just to understand how can we actually start to leverage the different digital twins and different type of data for decision support. So the key value for the digital twin for me really is make informed decisions. So making sure that we can have an informed, reliable decision, answer critical questions such as who is responsible for certain actions or activities, when certain actions and activities should happen, and how should we react to a particular conditions, ultimately to carry out key critical activities. So digital twin concept is ultimately quite simple. You have a physical twin and the digital twin. You can start to query the physical twin. You can start to ask all sorts of questions. And again, we can go back to this concept of Alexa or Google Assistants, again, voice control or any type of interfaces. But the key concept here is that we are collecting the data from the physical twin about the digital twin. We are having a number of insights based on the data, and making informed decisions to plan interventions, because ultimately it's not just about having insights, but making sure that we can plan interventions accordingly based on the provided data. And again, those interventions hopefully will help us realize certain outcomes, whether these are financial, performance-based, or maybe potentially sustainability-based. And some of these questions, I have actually put together a few examples of the type of questions that we might want to ask a digital twin. So here, who has the maintenance contract, or what is the current energy consumption, or other type of questions, for instance, how many square meters of floor do I need to clean this week, and so forth, which might, again, help you to plan operations and maintenance of this particular asset. But in construction, it's also useful because you can start to, again, ask certain questions. So when is the element going to be installed? Who is going to install it? How do I install a particular element, or other type of questions? So again, it's not just for operations and maintenance, it's across the full life cycle of the asset. The problem, nonetheless, we have is that only, based on various studies, only about 1% of data is currently analyzed properly. It is estimated that just 3% of data is currently tagged and ready for manipulation. So it's not really a volume problem. Infrastructure projects have a lot of data, but we need to learn how to leverage the data. Ultimately, the digitally enabled infrastructure is about connecting, first of all, the as-designed description. So here we're putting together the contracts, requirements, permits, or other type of information which tells you what is allowed to be in here. We're also looking at other type of information, such as what is actually here. So this is the physical configuration of the asset. So we can get it from inspections. And then on the other hand, we have information management systems which tell you what we say is here. So this is the as-built configuration or description of the asset. The key concept is linking these three different type of let's say descriptions and configurations together and manage the change in a proper way. So when something changes in the requirements, we can also make sure that it's reflected in our design and is reflected in our physical configuration and also in an as-built configuration. And ultimately, based on these, we're also able, especially in operations, monitor the conditions, because we want to make sure that we understand what the asset has been designed for, what type of performance we should be expecting from this particular asset, and then we're linking this back to the physical, what's actually happening in the physical world, and the as-built description as well. So the digital twin is really about linking all these different concepts of information and also condition monitoring and change management, change control. So what are the building blocks for infrastructure digital twin? We have been working for about 2 years now on this model. This model, we call it digital framework. And the key building blocks are the 5 enabling blocks, which are strategy, culture, organization and talent, or digital platform and digital assets. And the digital twin is actually one type of the digital asset. We then want to leverage these capabilities in digital workflows. So we have we distinguish two types of digital workflows. Those are project workflows, so capital project phase, and operational workflows, operational phase. Obviously, as we go and we execute these workflows, we will feed the digital twin with additional information, new data, so we have a constantly updated digital twin. The concept I want to highlight here is that actually the benefits are not realized through these enabling dimensions. The benefits are really realized through the workflows, through the digital workflows. So we need to focus on which type of workflows do we actually want to enable here. So some examples here, from the strategy, we have integrated digital and business strategy, because it ultimately we cannot act in isolation. It's not just about an IT job. It's really a digital business strategy that helps to achieve business performance indicators as well. We have organization and talent here. We're talking about things like governance, KPIs, roles, responsibilities, talent, and leadership. Digital platforms, you might have heard about connected environment or other type of capability, data quality. These are some of the examples out of the framework. And finally, the data-driven mindset. Again, it's all about people, making sure that the people are enabled through technology and through the process. So here I have highlighted the three elements: data-driven mindset, roles, responsibilities, talent, and leadership. And the reason why I've done it is because I want to highlight that actually what we need to understand is that about 70% of change efforts fail. It's for a variety of reasons. I have brought here some examples: lack of a vision, it's not communicated maybe, lack of a process is not documented, is misunderstood, or maybe we didn't enable our workflows to execute on these new behaviors. And one of the concepts is, again here, is that it's about bringing up the maturity levels within your ecosystem and stakeholders. So we're starting at a certain maturity level, we want to bring the maturity level up. I'm not going to go into the details, but you get the gist that we're going through a very basic digital twin where we still need to have certain outcomes defined, to a more connected digital twin where we are also leveraging advanced analytics. And when we talk about supply chains, especially if you have large infrastructure projects, you will see that we need to enable them, first of all, through this learning curve. There's going to be a learning curve where we're building up this capability to execute on a workflow. We achieve certain new behaviors in business as usual, and we also want to make sure that we will protect this capability, because there is going to be another curve, the forgetting curve. People start to forget, so we need to make sure that we have certain interventions in place to avoid that. And then we can introduce this continuous improvement concept, and again, this is a new curve where we're actually introducing new capabilities as we go along, because it's not just a one-off strategy. We're not putting in place workflows just all at once, but we want to make sure that it's a continuous improvement methodology. So some of the programs that we've been designing for some of the major infrastructure projects here, you see, give an example of envisioning and onboarding programs. We're really tackling the fact that we want to provide an understanding and awareness about the digital vision and strategy. We want to make sure that the supply chain is familiar with the processes, procedures, and make sure that everyone adopts this digital workflow. So for sure, what I'm trying to recommend here is to look at it as a process, as a data strategy, but also as a people talent strategy as well. So last but not least, I wanted to invite you to our Year in Infrastructure conference. It's happening in a couple of weeks' time, actually. So feel free to Google Year in Infrastructure. We're going to be covering a number of exciting things related to digital twin and infrastructure. So thank you very much for your attention. I hope it was useful, and I'm very happy to answer any queries you might have.
Thank you, Jakub. It was an inspiring presentation, and I think that we have the feeling that the future of infrastructure came to us today.
The advantage of organizing online events is that we can easily teleport. I'm sure that you heard about the Rail Baltica project. We have the pleasure to host a guest from Latvia, Mr. Raitis Busmanis from RB Rail, head of virtual design and construction. He will tell us more about Rail Baltica BIM implementation. Raitis, over to you.
Good morning, everyone. I'm going to talk about implementation of BIM in Rail Baltica project. My name is Raitis Busmanis. I'm the head of virtual design and construction here in RB Rail. and I've been in this company since beginning of 2018. Before that, my journey was in Trimble Solutions, and in general I've been involved with BIM since 2012. So in this presentation I'm going to talk about development of Rail Baltica project in general, then some words, not some words, but main focus on the digitalization, first results and first acknowledgements. Development of Rail Baltica project and what it is. So Rail Baltica project is 870 kilometers long new railway line between the capitals and cities of Baltic states. So it stretches from the north, from Tallinn in Estonia to Polish-Lithuanian border down in the south. Overall, it's, as I said, 870 kilometers, and currently we are in the design phase, and this design has been split into 9 sections, 3 of them in Estonia, 4 of them in Latvia, and 4, currently 2, but overall 4 will be in Lithuania. So overall 9 sections. As you can see here, there are some numbers about bridges, railway viaducts, road viaducts, aqueducts, segregated pedestrian crossings, tunnels, and different structures along this line, which is a huge number of structures and in different places of the line. This is all joint Europe effort to create this line and this railway, and this number of these different companies is just growing as we are now advancing into the design stage and soon into the construction phase. So all of these companies the number of participants will just grow and grow and grow. About the digitalization for this project. So we started our roadmap back in 2018 with developing a BIM framework. It was followed by a detailed BIM strategy and all of these detailed instructions for the market, and we sent also a message to the market that that these rules and these technologies are coming, so embrace yourself, be ready, be prepared. Then we continued with procurement of software. So we as a client, we didn't have basically anything at the time, so we started to build everything what we need, all the ecosystem of different solutions and different technologies around BIM and around it. Then we are into the design at the moment. So this is how I would describe where we are right now. So we are still learning, we are still defining and fine-tuning some things during the design process, and soon we will enter the construction stage. And the main goal of all of this, what we are doing, is the operations and maintenance phase. It's all about the information that we want to collect and want to reuse into the maintenance phase of the railway. Other than that, it's not point of it. There is no point, we see that there is no point of doing BIM just for the sake of BIM. There is no point of doing BIM. I call it doing BIM, but well, using this technology only in the design and construction. But the main target or the main focus has to be and must be at the operations and maintenance phase. Talking about our strategy and our standards, they are publicly available in our webpage. You can go ahead and download them. You can find them in our webpage. You can contact us, leave us a comment, question, whatever. So just for your information, all of this information is available online. When we talk about BIM, we usually talk about concept as a common data environment. And our common data environment is not something it's not one data repository, it's not one place to store the data or something like that. It's a ecosystem or different solutions around that, and the main goal and the main target is to try to join them, to fit them, so that to understand what each solution does and for what purpose it is, and integrate them, and this is what we are now focusing on and putting some effort on, is to make these solutions work together and to understand how to transfer the information from one place to the other, how to make these systems work together, so to avoid as much as possible manual work, to avoid data duplication, and so on and so on. It's not easy, it's not straightforward process, but this is where we are focusing. If we talk about some results, as I said, we are currently in design phase for the whole Rail Baltica line, and we have split the design in sort of 4 major phases. So it's site investigation, value engineering, master design, and detailed technical design. And it's not that you can translate these LODs for BIM standards like straight to 200, 300, 400 for each stage, but this is sort of the approximate number or the target number for each stage, what we want to achieve when we advance into each of the stages of the design. So of course it depends from discipline to discipline, from model to model, and from item to item, but this is sort of the approximate target number what we want to achieve. And by here, LOD is level of definition, which consists of level of geometry and level of information, and this information part is of course very important, as I said. Here are just some examples of how the information is being reused. This is about LiDAR data, and LiDAR being used as one of the means of collecting existing information. And of course, collecting this information, there is no point of just collecting for collection's sake, but of course this information has to be reused. And as our project is mainly greenfield project, we reuse this information to model the existing conditions, so that we can calculate more precisely the volumes and earthworks, and there's a lot of emphasis in this to collect as much as possible precise data, so that the calculations would be as accurate as possible. It's not just about what is above surface, but it's also about what is below the surface. So here is an example of the geotechnical information and geotechnical data collection, and representing that data, reusing that data, and as again saying, reusing the same information in different platforms, different solutions. So this is about geotechnical and BIM environment, and here we can transfer the same information what we have collected. We can transfer that the same information into the GIS environment. It can be 2D, it can be 3D, and there are different ways of reusing information if you have collected this information, and if you have structured it and you know the purpose and what you want to achieve with this information, then there are different ways how to reuse it. It's just a matter of defining and developing some standards, and developing some ways how to reuse it, and how to make best out of this information. Here you also on the screen you can see ortho photos overlaid with topographical data, overlaid with geotechnical investigation data, and putting it all together. Another way how to review or how to follow the status of what is happening. This is about geotechnical data, how much have been done for this particular section, what is the progress, what is the status, and so on. So you can follow this information if you have it, if you have structured it, and you can reuse it in many different ways. Just some screenshots here from what is there in the BIM model on the top, together with the LiDAR data, together with topographical surveys, and the visualization. So when the visualizations are created for PR purposes, for using it in a public, for municipalities, communicating the information with different stakeholders, you can reuse this information. It's not necessary to create a new information. You can just take what you have already in the BIM model, reuse that information, and create these visualizations, and or reuse the information in different means. So, for example, here we have a BIM model, we have a visualization model, and we have the same BIM model, structural BIM model, inserted into the GIS environment, and also combining different means of information and putting it all together so that all of this information is working together. We here in this example, it's a Revit model, but but mainly our strategy is focused around IFC. So we want to transfer, and we are trying to transfer as much as possible via IFC. So this allows us to use different solutions, different softwares in developing the design, and as we have, as I said, we are a public company, we are public procurer who is working as a client. So we have different consultants, different design companies working for us, and we have defined the standards and the ways how they should work, but the software is basically up to them, as long as they can compile or they can comply with our requirements. And IFC is being one of those requirements, and attribute data within IFC is another requirement from our side, and we expect to delivery of this information in many different in not many, but in this certain way, how the information is being categorized, how the information is being structured. So, for example, here is from one model an example, a screenshot where all of this information is structured, what we want to collect about every object, every asset, and what we want to reuse later in different ways, in different scenarios, when the railway line goes into operations, and we have to maintain this information, we have to maintain these assets, and this information has to be there embedded so that it's possible to reuse it. Another example here, I have blanked out some items here in the attributes due to some security issues and reasons, but you can get like an understanding of what kind of information we are collecting, how it is structured, and what we want to achieve with every line and every attribute that we are collecting this information. So just to end my presentation and focus on some first acknowledgements, as I like to call them, is you have to set clear requirements, you have to follow the progress as a client. It's a learning curve for everyone. It's a learning curve for designer, it's a learning curve for consultant, and it will be a learning curve for the construction companies as well. But you have to demand the result as a client, you have to dictate the rules, but of course you have to remember that a certain degree of flexibility is good, because the technology not always is there, and you have to think about the big picture. So why are you doing this? What is the purpose of collecting this information? What is the purpose of these BIM models? What is the purpose of different technologies? And BIM, as I said, is not alone. It's just a buzzword that's been used in the industry for the last couple of years, but actually there's a lot of different great technologies around it. As I mentioned already, GIS, for example, and we see also GIS as being one of the core technologies around our strategy as well, and how to reuse what we have collected, all of this information. And new things are hard. That is the last thing, and everybody must learn, and it's not easy. You have to put a lot of effort to get this information, to structure it, to put it all together. It takes a lot of effort, a lot of learning, and new things, they are just hard. It is what it is, and it will not come straightforward and easy. But with that, thank you very much. This was my presentation. I hope you enjoyed it, and I hope that the technology allows us now to answer some questions if you have any, or if not here, then please send them. You can find our contact information in our webpage. So thank you.
Thank you, Raitis. Indeed, it's a very complex project connecting the Baltic countries and the rest of Europe. We've been keeping our fingers crossed for the success.
Railway infrastructure is a key priority not only for Central Europe and Baltic states. Now you will be able to learn about Crossrail, which is one of the most significant railway infrastructure projects in Europe. Please welcome Mr. Malcolm Taylor, who will tell us about the need for integrating strategies on digital, on procurement or innovation. Malcolm will use real examples of smart digital solution in practice. Malcolm, the floor is yours.
Hello, my name's Malcolm Taylor, and it's a real privilege today to be able to give you this presentation on Crossrail, delivering digital solutions on behalf of Crossrail International. My background is I'm a qualified chartered engineer, and for over 10 years I was head of technical information at Crossrail, responsible for many things like information management and some of the technical aspects of BIM and the like. Today I work for Crossrail International, which is actually a UK government-owned organisation committed to supporting clients worldwide in delivering their rail projects. And if you want to find more of us, you can find out on our website or on LinkedIn. Today I'm going to be actually giving you a brief introduction to Crossrail, talking about some of the critical digital aspects of creating smart infrastructure in Crossrail, and give you some examples that we see as best practice in that area. As a brief introduction to Crossrail, it is a very large project that runs over and underneath London. Twin tunnels, 21 kilometres of twin tunnel underneath London is the most complex section, but we're using full-size 200-metre long trains, delivering over 200 million journeys a year, which will increase rail capacity into London at 10% at a stroke. Digitally, they're also very large, over 250,000 2 and 3D models, nearly 4 million documents, and with a million pieces of equipment and assets, all goes up to make a very expensive project, one of the most expensive projects in Europe at this time. Program certainly has been a challenge to us at the moment, but the cost has varied up and down. Certainly is not too much more expensive than the original budgets, and standards have come and changed as we've gone. But the thing that I think is most interesting in the digital field is the way in which the things have changed. When I started back in Crossrail in 2009, things like iPads and tablets weren't even in existence, but now we talk about Wi-Fi at stations, the Internet of Things. There's a degree of complexity that time gives us across these major projects that we have to consider and exploit, otherwise we will lose the advantage in a digital sense. And it's important that we as clients recognise how we need to capture that. We have contractual complexity, over 120 different types of contracts need to come together, and data and information is the glue that provides that consistency and interface across all of them. There's construction complexity. London's a very expensive and environmentally sensitive place to work, and some of these constructions here at Liverpool Street, our platforms actually join two existing stations. That's the scale of the construction that we're actually doing underneath London today. The role of the client in digitally is very critical. We, as owners of all the infrastructure, need to spell out and define the strategies that we should take. That in turn creates the collaborative BIM environment, and the need is to drive that across all of our contracts, and that's where procurement is so critical. Procurement and making sure that the strategies that we have for design, delivery and for digital actually come together and are appropriately integrated to ensure that they all work together and we get exactly what we want. Some of the basics that we have in digitally, we talk about building two railways, the physical and the digital. We talk about BIM, the world of 3D modelling, how critical our 3D models are in the early days for designing but also the data models, things like condition profile of assets, also when we should repair and replace assets. Those models are all models that come into our BIM environment. So going digital has just a number of characteristics. We need to define the end games, not just about what information requirements we need for operation and maintenance, but also for building and creating the railway. We need to think of a common collaborative data environment of where we put all our information and how we leverage technology to get there. And just think about making sure we get the basics, the asset classifications in place, location codes, design disciplines, contract codes, get all of those basics in place at the beginning. Absolutely fundamental to creating a smart railway. And even simple things like standardized document and data ID systems, absolutely across all of the contracts as standard. Recognizing the relationships between different types of information, and that particularly once you start adding sensors to things and using smart data analytics for managing performance, which is where digital twins comes in, there is an information loop that provides feedback for the way in which information works in these railways that we mustn't forget. It's not a static world that we live in terms of data. It's a live, interactive world, and we need to capture that. So we need somewhere to store a common collaborative data environment. We talk about a single source of truth that everybody, including us as a client, we require to use so that we care and share with all our information in one place. For us, it really mostly comprised of 3 linked databases, and we actually used workflows instead of lots of different bespoke pieces of software to undertake all of these different activities, including £8–9 billion worth of contract management, just within workflows in our databases that were part of our collaborative data environment that drew everything together in that efficient way. Early days, we had a few workflows in our design contracts, but over time, built up those workflows to manage and maintain our construction contracts as well. And the benefits were very significant. Reduction of the loss of data at each of the design phases, but overwhelming commercial benefits coming out of the way in which collaborative data environments can work, and the benefits were evidenced on our project. Some examples of the best practice: we had to create designs and standards to explain to people how we wanted them to use our systems, to how we wanted people to work together. In our 3D world, it was not about teaching people how to manage design in 3D, that's been going on for many years, but it's about the management of space by different disciplines and different organizations. It's about using 4D to help us as client understand the way in which, for example, some of our station contracts interfaced with our tunnels, how some of the major station access shafts were being constructed to show people about how they were going to be created. And even here, where we had some of the floating track slab being constructed in very confined spaces to show how that would happen in 4D. We would take the models onto later on our projects, to many of the sites where the models could be used to help create progress reports to show how mechanical, electrical and public health would be installed, so we could control and manage installation over time. Using those models saved significant amounts of money over conventional ways of working. And where we had in our tunnels all sorts of equipment needed to be supported, 250,000 holes to be drilled, the contractor did a 3D point cloud survey to understand exactly where he couldn't drill, and used an automated drilling machine to drill exactly where the 3D model would tell him to be able to drill effectively and efficiently, saved by a factor of 5 in terms of our program times using this method of construction. Also giving the models to our contractors for information so that they could develop new ideas and ways to improve, and certainly off-site manufacturing evidence to show how beneficial that was. A couple of other thoughts. just as in you create the physical world of concrete, you take concrete cubes to check quality, here in data and information it's the same. Create and check the quality of your information as you create it. Don't wait till your site's to be completed. Very critical. Also, where we had, because of that timeline and a change of innovation, we used an innovation initiative to tease out a lot of ideas, over 1,100 ideas from our supply chain, where contractors and Crossrail put money into a fund to produce lots of innovative ideas. Very critical for me, because of that 100 funded ideas, a third of them were in the BIM and information management world. And absolutely unequivocally, every 6 months, over a period of 3 or 4 years, when we went and audited the performance of our contractors, those contractors that were performing the best in terms of program, commercial, health and safety, quality and information, those ones that were performed the best were always those contractors that were innovating the most. And so, although it can be counterintuitive from a project management perspective, encouraging innovation was critical. Well, finally, everything I've talked about and a huge amount more is all on our Learning Legacy website, which I would absolutely commend to you if you would want to find out more about Crossrail. But looking at Crossrail in numbers, it is a very large project with many thousands of users, many thousands of organisations coming together to create one railway. Going digital has absolutely made that possible, and I would commend to you that all projects should be digital. That approach from a collaborative data environment, understanding what you need to create, produces much better decision making with very positive outcomes in terms of costs and benefits. But you absolutely do need a digital strategy to make that happen. So, as I say, it's been a real pleasure to be able to be with you today and to have the opportunity of talking to the Smart Infrastructure Conference. So, thank you all again.
Malcolm, thank you very much for your excellent presentation. We hope that we will be able to take the first ride on Elizabeth Line soon.
And now we have a pleasure to introduce live Mr. Piotr Dudek, representing Association of Polish Engineers in Great Britain, and Mr. Piotr Seges from SPI. Our speakers will share the key points from their experience in using BIM at most extensive infrastructure investments. They will demonstrate how to transfer the UK project's expertise to the Central and Eastern European markets. Piotr, over to you.
Hello Sylvia, hello Marek. Hello. First of all, I would like to do some short introduction. My name is Piotr Dudek, and I've got privilege and pleasure to present information about the BIM. I will do that together with my colleague Piotr Seges. Hello. Let's go to my presentation. Before I'm gonna do that, I would like to tell you about my experience from United Kingdom. I spent wonderful 15 years in London, do some BIM projects like Heathrow, Terminal 5, Olympic Village, Blackfriars Bridge, and then I jumped to the client side to do the Crossrail and Network Rail projects. That is giving me some knowledge about the BIM, and today I would like to share that knowledge with you. Our agenda, BIM around us, and in few words, we would like to tell you where we are with BIM around the world, around Europe and in Poland. And then we would like to give you some practice examples, how to implement, how to use BIM. Let's get first answer. What for? According to the government strategy, we can achieve around 33% savings. So lowest cost, that's what we have to remember. 33%. It's quite worth to think about the BIM. Obligatory BIM around the world. That slide is showing everyone BIM is around us. It's almost everywhere on the places where we've got infrastructure projects. In Europe, Polish neighbors, Germany, decided to start implementation from this year. Lithuania thinking about next year. Czech Republic, 2022. So everyone is thinking about the BIM. Central Europe and Poland, where we are over there. It's a pleasure to say some rail projects like Rail Baltica or Solidarity Transport Hub in Poland, thinking how to implement, is creating the strategy now. The private sector already knows the rules, already knows what kind of benefits they can possess from the BIM. We've got some examples of the recent BIM projects in Poland. On this particular slide, those pictures, they are showing few general examples, but believe me, majority of the investors, yes, they know what is the BIM and what kind of benefits we've got from that. Also, in Europe and in Poland, we've got some initiatives. Let's say BIM standards is telling us what's the best road to implement the BIM. infraBIM is supporting that process to the public sector, to the private sector. STP, Association of Polish Engineers, Great Britain, decided to create a special program, special project, which we're calling BIM for Poland, to share knowledge, BIM knowledge from UK to Poland. BIM in practice. Examples. How to do that? SPI, Specialist Project Integration Company, has got massive experience about the methodology. It's covering all subjects. It's starting from strategy, going for the training, and full implementation. To achieve the success, you have to know the subject. So let's talk about 4D and infrastructure modeling and simulation. We prepared for you some program simulation from Liverpool Station. If you've got some massive infrastructure project like this one, similar to the train station in Warsaw, which very soon will be rebuilt, you can see on the right-hand side hundreds of tasks to achieve. Achieve the milestones. And if you have to be 100% sure you'll be on time, on budget, you need something which is going to give you that. That's the 4D program. Anytime, anywhere, you can get the information where we are with the project. So one source of truth. If we've got that first step, we can easily jump to another achievements, which is 4D, which is augmented reality, etc. Let's go to the next subject, which I would like to briefly discuss, common data environment management, support document control. On the left-hand side, you can see traditional information sharing. That is showing you the information is going from client to the manager, from manager to engineer, so it's a long road. We are losing time and money. To avoid that kind of problem, we should use BIM methodology, which is create one source of truth, common data environment in the middle, and create simple access to that information to everyone in the process. And then you've got guarantee. The information is always in the same place and always is available. We can use that information for different purposes, like progress, like assurance, like safety on site. I would like to thank you very much you listened to me. And now I would like to ask my colleague Piotr, could you please tell us something more about the project control?
Thank you, Piotr. Piotr has just explained about BIM around us and about effective tools that you can use to deliver the project successfully. Now I would like to focus a little bit on something what is between the tools we use, between people, and between systems we have. So it's very important to use good tools, and it's very important also to connect the tools together, to connect them with the systems, to make people connected, to have the information in place when we need the information. So in this part of the presentation, I will share a little bit more about SPI Command Center and Smartsheet. Next slide, please. On the project management side, we simply want to keep control over the project. So we want to get real-time insights from the site. We want to be sure that we are on time and we are on budget. Very often there is high risk that the reports that we receive are not based on evidence and just cannot be trusted. Very often there are many manual processes, copy and paste, manual handling between various Excel spreadsheets, between various softwares. Another very common problem is connected with data silos. So if data are not available for people who need to use them, if we have designers and contractors which are waiting for the data, it tends to lead to design programs and construction program delays. And finally, we have claims, and we have dissatisfied internal and external stakeholders. So one of the key way to overcome that challenge is SPI Command Center based on Smartsheet. It connects all the data together. It connects time, cost, schedule, program, budgets, creating an integrated environment with single source of truth. So we know where are the data. We know that the data are recent, and we proceed in seamless, smooth way. Smartsheet basically, in basic form, looks like Excel, but everything is connected. It's also equipped with project and portfolio management, reporting system, it's intelligent database, and all of that is in one system and in one environment. Going digital, so effectively we eliminated paper on our projects. The idea behind that is to digitize the project and avoid repetition, avoid manual handling and human errors which appear there. So it means that we are collecting the project the data once at the source, and then we process their automatically between various softwares using proper gates. So we are sure that the data are in the place they should be at the time where they are necessary. So it's very, very important to provide the data for the people they need them to progress their work, so we don't cause delays because of the information blockages. So the practice shows that implementation of effective project control tools can improve productivity by 20%. So 20% on the projects where we involve hundreds of people. So we think it's really significant amount, and we have to keep an eye on this part of our activity. It's worth to mention that Smartsheet is used not only by companies from industrial sectors, it's used by governments, by administration, logistics, production, and many other companies around the world. To conclude, we believe that there are better ways to deliver the infrastructure projects, and this is important to have good mixture of tools, of methodologies, and systems that create one integrated environment which can allow us to execute the project successfully. That's all from my side. Thank you very much.
And we would like to use that opportunity and say thank you, to Infra team and Marek. And also we would like to thank you to Sylvia.
Thank you very much, Sylvia. So we would like to express our great gratitude for cooperation in preparation of the Smart Infrastructure Conference to the Department of International Trade of Great Britain. Thank you. So
it is a pleasure
very
for
nice
us
event.
as well.
Thank you very much, both of you.
Thank you very much. Thank you for exciting presentation, both Piotr and well, Sylvia.
So we are now finishing the second session. I hope that you are still with us as we are approaching the panel discussion, which is one of the most exciting part of this conference. See you after the short technical break. We will be back in 5 minutes.
1 p.m., sorry.